Hello, I'm Danny from CG Dreams, and today we are going to be talking about the basics of UV mapping. In this video I will be covering what tools you're going to need, some basic terminology, modelling considerations and troubleshooting. In 3D graphics we use 3D models, and these 3D models will at some point need colour. We can use a material on our 3D model, and in the application we can apply a whole colour to the whole entire object, but in some cases we need to be placing specific details of colour into specific areas. For this we need to apply a 2D image to our 3D model, and this is when we will need to aid our 3D software to understand how a 2D image gets wrapped around your 3D model. Your model is made up of components, faces, edges and points, often called vertices. The components that I was concentrating on in this particular case is the points. The points on your 3D model will all have a position in 3D space, and all have an order in which they are placed which is unique to your 3D model. This is called the point order. When we make a UV map for our 3D model, every single point on your object in 3D space has a location in the 2D representation of itself in a UV map, and it's this map in which 2D images are applied to. Your 3D model is defined by a coordinate system which tells us which is up down, left right, forwards and backwards within 3D space. A number system is used for this, in which y-axis is for our up and down movement. This could be used in a positive or negative way, up and down. It's often given the colour green. For the right and left movement, the x coordinate system is used, and this again could be used in a negative and positive movement for the left and right. Finally, the forward and backward movement is represented by the z-axis and is often given the colour blue. The z-axis is what gives our models the 3 dimension, which makes it 3D. This basically gives it the depth. When we are dealing with the UV coordinate system, the two letters in our particular case is called the U and V. The U stands for the horizontal position and the V for the vertical. We give the UV the added term map because it is a map which helps us and the 3D software to know what location each point of our 3D model is located in our UV space. Hence we link the 2D world to the 3D world. If we were to apply this in a real world example, let's say for instance we were to unpeel a lemon, we would have to think very carefully where we would cut or make a tear. We would also need to think about the best place to do this in order to get the best and neatest job done, so that we can flat pack the orange peel onto a tabletop. Our aim would be to flat pack the orange peel flat on the tabletop. In essence, this is how the unwrapping is done in 3D. An object that is 3D is flat packed into a 2-dimensional object. To re-emphasize on this, in 3D we aim to do a similar job. We need to flat pack our model 3D into what's called a UV map. In 3D modelling we must first carefully plan where to cut by selecting seams. This is where we have the edges of our model. We can loop around an area such as the neck, the wrist, to create a cut which will separate the part of the UV map and help us get a better flat pack overall. Once we have the seam selected, we would use a cut tool, then the unwrap tool. The unwrap tool would then try to work out the best way to flat pack the 3D model by its inbuilt algorithm. Once we do this, we can then use the relax tool to get a better unpack to become more even and distributed. We can then orient the pieces, scale and place them where we desire within the designated tile or the UV space. During the modelling process, we would do well to think ahead where our seams are going to be and where we're going to be cutting them to get the best UV map. We do this because at times these seams can produce render artifacts. For this reason, we want to try to choose seams on the model where they are hidden, such as under the armpit of the character or down the inner seams of the legs. Another problem is the UV map needs to represent the same spacing between each point on the 3D model. Some polygons on the 3D model are smaller than others and thus needs to reflect this as much as possible on the UV map itself. The UV map must be as distortion free as possible. So if for instance there is 4 points that make up a polygon on the face that is small on a 3D model but very large on the UV map in relation to other polygon points, it will create distortion when an image is applied to the 3D model. The Relax tool tries to eliminate the distortion as much as possible, but ultimately it's the seams and the placements that are cut that basically give you the best unfold and relax. When a single 3D model is split into multiple parts, islands, or remains as part of a single unwrap, under no circumstances must any area overlap each other. If this should happen, what you're going to get is you're going to get the same colour information being applied over 2 different areas of the 3D model that may not want to be applied to. In some cases we do intentionally overlap the UVs so they get the same colour information. This can be some areas like the fingernails, which are relatively similar in nature. Each UV island should remain the same correct scale in relation to each other according to the scale of the 3D model. This is for when you desire the whole model to get equal distribution of quality from the texture map. However, in some cases we may want some areas of the model to have more detail. So we scale the island larger, for instance the head of a character. This could be considered more important at times than the body. The more space an island gets, the more pixels it occupies, which means more detail can be placed on that particular part of the model. When the UV map is complete, we often save out what's called a wireframe template, so we know where in our 2D painting software, where on the model we need to place the details. Photoshop, for instance, can load these templates in as wire backdrops. Then we can make a new layer to start painting on or start patching down photo references. You can also choose at this particular point how large you want the overall map size to be. This is often done in increments of a 256, 512, 1024, 2048, 4096 and so on. These determine the different size maps and they're normally referred to as 2K, 3K, 4K, 6K, 8K maps. That's normally the order in which we normally apply or make the size of the maps. The larger the map, the more pixels we have, which means more detail we can add to our texture map. The texture map can then be exported from our 2D painting program and applied to a 3D model, in which has the UV map for the same template we used to place the details on. The texture map then gets wrapped around the 3D model and shows the detail on the correct places on our 3D model. Aside from the colour information, texture maps can also hold information that deforms the object by using grey, scale and colour information to displace the points of the object in 3D space. These types of maps are called displacement maps. We can also create fake maps which use lighting in the scene to produce shadows and the surface details such as skin pores. Again, these maps can be made which the UV map is relying on, and these are called bump and normal maps. We can also control many aspects of the material, such as how glossy a surface is, where the hair can grow off an object if your 3D application supports this, as well as many other control maps. I hope you can see from this the importance of a high quality UV map and the software that you use, because many texture maps have to be made for one single object, and in some cases it can take longer than the actual modelling process. It would therefore be wise to pay special attention to your UV mapping and to use the best tools that you can afford for the process. The UV unwrapping process can be a very tough job, but it can also be a very fun job depending on the quality of the model, if it's been thought out well where the edge loops and the edges are going to be. In this chapter I'm going to be unwrapping a character in my chosen software, Unfold 3D version 9. Most of what you see done here can be done exactly the same thing in other applications. The only difference is how easy the application makes it for you to achieve the same results. In some particular cases the algorithm will be completely different in the way that the software unfolds. Unfold 3D does a very good job of relaxing the mesh and therefore makes it much more easier to do the job. So I've loaded this character into the 3D software Unfold 3D version 9, and the first thing that I'm going to mention is make sure that your model, if possible, to be completely 100% symmetrical. The reason why you may want to have this is because it makes the process significantly more easier, especially when it comes to UV mapping areas such as the face. So the first thing I'm going to do is I'm going to activate the symmetry. And you can see here that half of my model is actually being masked off, indicating what side I need to be working on. Now there are many ways in which you can place the seams to unwrap a 3D model, and I'm just going to show you one way. So I'm going to go ahead and first of all select all of the seams using a combination of two selection types. I will select between one loop area and another, or I'm going to select around complete loops. And these are the two tools that I use from this. So this will use the shortest path. Let me just show you what I mean. So with the edge selection and the shortest path, I can select one edge and then go to another area and then select the shortest path where I want it to go to, and it's automatically going to select all of the edges between that area. This makes it very quick to select along limbs such as the arms and legs. The other type of selection is loop selection, and this is it's going to create a complete loop selection around the entire area. So for the first part in this video, which I'm going to speed up, you're going to see me select all of the edges that I wish to make a seam eventually to be cut. Now I've gone around all of the areas in which I want to create the seams. I've specifically chosen to go in the inside of the arm, the inside of the legs, and I've chosen particular points around like through the hand here, so it's equally cutting it around the middle of the hand, and you'll see why in a minute. It does take a lot of practice to see the outcome and understand what you are likely to expect, but this comes with time. The next stage is to unfold. I've done the cutting, it's indicated by all of the orange edges that have been selected, and then I'm going to select the unfold or the U key. You'll see now that it's automatically unfolded everything for us. Now there's a particular option in this particular application, which is prevent cell border intersections. This means that basically it will prevent any borders from overlapping each other, which is a really good time-saving feature. The next thing is I want to reorientate and place each individual part within one UV island. Or if I'm going to be using UDIMs, see my other video, then I can apply different parts to be in different UV tiles. For this particular instance, I'm going to place everything within one UV tile space. For this particular part of the video, I'm just going to be using some very simple tools: the move, scale and rotate. At this stage, what I want to do is I want to use some of the packing features, and this is the same in all software. What it will do is it will automatically pack it into a specific designed UV space. In this particular case it's here. So what I'm going to do is I'm going to just click on the pack, and it will pack it to fit and make the most of the UV space. In this particular case it's taken up too much because I need some room for the head, the hands and the feet. So what I'll do is I'll scale this down and then just move this into place at another place. I think that should be about right. I'm going to do exactly the same thing for the head. I'm going to move the head so that there's no overlapping, and I'm going to scale this up. Move the hands over to there, and then I'm going to move the feet down to here. Now note that I am scaling these parts of the body differently so I can fit them onto the UV map. So in a way I'm sacrificing some areas of detail for other areas. Initially when I done the unwrapping, you'll find that everything was unwrapped in proportion. In other words, the head was the correct scale in the UV map to the way the body was, as is the hands and feet. But because I'm limiting myself to one UV tile, I need to make some sacrifices in order to fit everything in the same UV space. As things stand right now, this would be quite acceptable. However, we can go in there and apply some relaxing to make the UVs even less distortion. When you look at the individual islands, these here, you'll notice that they're given colour. And the colour is basically a heat map, a stretch map. And it tells us basically which areas are good and which areas are bad according to distortion. A bad area would be somewhere which is in the red zone. A good area which is pretty much within the blue zone but a little bit too small. And somewhere in between which would be ideal and perfect. So you're kind of looking at a grey area which would be just about right. You can clearly see here that these red areas are the back of the eyes and the back of the mouth, the inside of the mouth. And it's for this reason that I would go in there and I would just remove these as part of the 3D model so that the face can relax and look a little bit more better than it does now. Now what I can do for this is I can isolate this island here so that it doesn't affect anything else in the scene. So I click on isolate and then you'll see that only the head is visible. This makes it a little bit more easier to work on. We can get right up close there, and I'm going to select my loop selection tool. I'm going to go on the inside of the mouth. A particular feature which is good about this is wherever I place my cursor on an edge, I can press the F key, and what it will do is it will create a focus of attention, a pivot point at that particular area, and that's very, very nice to be able to do. and of course then I can go and select loops as I need to around the area. So you can see here we've got a loop here, and the loop needs to be continued all the way around. Press the cut and do exactly the same thing for the eyes. So if I just focus on the eye area, I'm going to take a loop around there. And it's a good idea to have the symmetry on when I do this. That's it, and then cut. And then when I press the unfold, it's going to resolve and look much better. And then what I can do is I can go in there and just separate these islands off. So that's, for instance, I want to keep the head where it is, but I definitely want to move the inside of the mouth away and the eye. If we just zoom out of here, we turn the symmetry back on, it looks like it's overlapped the back of the eye there, at least it's somewhere else. No, there it is. We can turn the symmetry off and then just bring everything back together. The next thing is you can still see some areas on the face which are looking still quite pink and red. This means it's where the distortion is. So what we can do is we can select this island and apply a relax or optimize in this particular case, and you'll see that it's going to do its best to optimize it so that it's more even. If I turn on the symmetry, you can see the lip here, it will make it right exactly the same for the left and right. Exactly the same thing for other areas that are symmetrical. We can optimize it so it's got less distortion, and then finally we can show everything and bring everything back. You can see in this particular case, and in most cases in fact, I find that I don't even have to use any pinning. And pinning is basically when you want to retain a particular area to stay where it is while moving another area, and there's some really good tools within Unfold 3 for doing this. So for instance, we can add a pin. Let's add a pin, say to here. We can select specific verts on here, and then what we can do is we can pin them. So let's just go to the selection tool, and I'm just going to go in there and say I want to select that vert here, there. Make sure I've got that selected. We'll select one of these edit modes, and we will add a pin. You can add auto pin in as well. I'm going to select these and pin these. Let's just pin these as well. And then I can start to move other verts. You can see here, it enables me to manually relax certain areas where I feel there's some pinching. This is like a really interactive way of working. You've also got some painting as well, that you can basically say that you want the software to allow more detail for the UV map to be in one certain area. As you can see here, it's going to create distortion, but distortion to our advantage. You can see here it's actually removing distortion in this particular case. And this one does the shrinking. If something's too large, it will do the opposite and shrink it. So there's some really, really good things that you can do with this. Now, if it's the case where you want your model, say for instance the face, to have a particular area to have a little bit more of the UV space, for pixel space, then what you can do is you can actually do some painting in here. And what the painting will do is it will enable you to either paint and optimize or smooth in a logarithm. So this is essentially doing the same thing as what this optimize does, but you're painting in a specific area. Or you can actually do some painting itself where you want there to be more density. I'm not going to go into too much detail about this, but it's really nice to be able to do this. If I wanted, say, this face area here to kind of occupy more of the UV space, you can do this. And these are kind of tools that you would expect to see in a good UV unwrapping application. So what I do is I go to the density map here, and I can change the color of the density map basically to how dense I want it, and it's going to change accordingly. So if I change the pressure, bring it up, and I paint like this, then when I do a optimize, it's going to optimize according to the density of the map, and it will basically smooth it out. So we can really get some optimization down on this, and it works fully symmetrical as well. So that's, for instance, that's set the pressure for like a pen, and we create where we want the density to be more focused on, say around this area here. And then when we do the optimize, you can see here that it's actually pushing this particular area more forward in 3D space, you could say, so that it's occupying more of the UV space. And of course you can apply more pressure to this so that it does the job more and more. So if I reset this and say we change the value to that, it's quite dense, and then do the optimize, you can see here that it's really optimized it to utilize more UV space. I tend to be using smaller values if I'm going to be doing this, and of course it's working with symmetry, and there we go. And then finally you can see here that we've got our UV map done in no time at all. And of course you can go in there and just sort of clean some areas up if you've just, like I've just noticed, you know, I had this part placed the wrong place there, and that's it. It's as simple as that. The main challenge with unwrapping is, first of all, when you're doing the modeling stage, you want to be thinking about where you want to place these seams for UV unwrapping. The next thing is the density of the model. The more dense the model is, the harder things can get. The other thing to consider is to get to know the logarithm. So when you hit that unfold button, you've got to kind of have an idea in your mind what it's going to look like. And this is something that can't be taught really. It's something that you've got to do for yourself to be able to understand and learn what the expectations are of where you place the seams as to what kind of unfold you're going to get. And this is something that you're just going to have to do by experimentation. There are lots of different ways that you can work with. For instance, the head is generally done the same way. It's normally cut with a loop around the neck, and then it starts from the back of the neck, and then it will stop somewhere on top of the head, and this gives you a relatively nice map. And if you wanted even less distortion, you could even cut it a little bit further down here, and it will give it more area to relax naturally. For the hands and feet, generally, as I've done it there, it is a case of cutting the hands off and then going around the midline of all of the fingers, and one end needs to be connected. If I can just focus on this here, one area needs to be connected to where the loop is on the hand, and let's just select an edge here just to focus on. You can see here we've got this loop coming to where the edge loop is, and then it's going all the way around, and then it's going to terminate, leaving one area here which is not being cut. And this is basically this line here that you can see. This line here is the area that hasn't been cut. If I was to select this. In fact, you should be able to see this. There you go, it's on this one here. So you see this line here. This is the line in which I haven't cut so that the hand can remain in one piece. So this is generally the way it works with all the 3D models. Decide where you want to cut it and where you want it to remain in one piece.